friends, I am Pooja Arora, Assistant Professor at Bayani Group of Colleges. On behalf of GuruKPA.com, I am giving you a video lecture on the subjects of discrete maths. In the last lecture, we have already discussed what is set, type of sets and subset and the concept of power set. Today I am going to discuss the operations on set, different operations on set. There are the list of different operations. For example, the first one is union, then intersection, then set difference, symmetric difference and the complement. We are going to discuss each one by one. For example, I am going to discuss union. For union, what we do, we have two sets, set A and set B, and we have to union of these two sets, and this is the symbol of union. Symbol of union is simply a U of English language. It's an English character U. For example, if a set A has 1, 2, 3, 4 elements, and if the set B has X and Y 2 elements. What is the union of the set is? Union of the set is a combination of these two sets, that means all the elements of set A and all the elements of set B, both are in the union set. So what will be the set of union? That will be equal to 1, 2, 3, 4, X and Y, all the elements of set A and all the elements of set B. If I denote it mathematically, then what will be the union? Union will be A union B equal to X, where X belongs to A or X belongs to B. Means if X is in A either or X is in B, it will be in the set of union. If X is in A, it will be in union. If X is in B, it will be in union. All the elements of two of set is in the union set. So this is a operation set. We can take any example and find the union. If I have some common element, for example, if I have here X and 5, then we have to find the union of these two sets. Then what will we get? We get 1 as well as X, 5, 4, all the elements of set A, and then the element of set B, but the common element will not be repeated. For example, X we have already mentioned, so we will not going to repeat the X, we will append it with Y. So this is the concept of union, in which union is either the element in set A or the element in set B, it will be listed in the union. Okay, and now the second operation is intersection. Intersection means the common element. What is it denoted by? Common elements of both set, and the symbol used for intersection is this, opposite of union, that is this. This is a symbol of intersection, and in the intersection we find the common element of both the set. For example, if I have a set A 1, 2, 3, 4, 5 and a set B 2, 5, 9, 11. Okay, and we will find the intersection of these two sets. Then what will be the intersection? The common element of set A and the common in both of the set. What is the common element? There is 2 in set A and 2 is also in set B, and 5 is in set A, 5 is also in set B. So 2 and 5 are the common element. So A intersection B will be 2, 5. So this is a set of intersection. For union, we will append all the elements of set A and set B. For intersection, we will find only the common elements of both the sets that are called intersection. So this is union and this is intersection. If I find the union of these two sets, then what will I get? 1, 2, 3, 4, 5, and now 2 and 5. These are I have already listed, so I am not going to repeat this. Then what I am going to write? 9 and 11. So this is a set of A union B and this is a set of A intersection B. That means the common element of both the sets is listed in the intersection set. Okay, so we have already studied union and intersection. Now what we are going to study is set difference. What is set difference? If we have two sets, for example, I am repeating the same set. That means 2, 5, 9, 11. And I am going to find out set difference. What is set difference? Set difference means a set A and a set B, and I am going to find A minus B. Okay, and if I am going to find B minus A, these are two different set. A minus B is not equivalent to B minus A. They are two different set. Firstly, I will find A minus B. What is A minus B? A minus B is set A minus set B. That means all the elements which are present in set A but they are not present in the set B. If I write it mathematically is X, where X belongs to A and X is not belongs to B. What is the definition of A minus B? A minus B is X, where X belongs to A but X is not belongs to B. These symbols we have already discussed in our last lecture, that this is a symbol of belongs to and this is a symbol of not belongs to. So X is in A but X is not in B. Okay. According to this definition, if I find the elements of A minus B, then what will I get? If X is in A, X is not in B, then I will consider it A minus B. For example, if I take 1, 1 is 1 in A, but 1 is not in B. So, I am going to take it 2. 2 is in A, but 2 is in B also. So, I can't take B because it doesn't fit in the definition. Third element is 3. I will take it because it is not in B. Then 4, it is not in B. And 5, it is in B, so I can't take it. So, this is the set of A minus B. What is A minus B? A minus B is X in A, but X is not belongs to B. This is called A minus B, set difference. And what is B minus A? I said already that B minus A is not equal to A minus B. So, B minus A is a different set. What is B minus A? B minus A is a set of X where X belongs to B and X is not belongs to A. The element which are in B but which are not in A, that will be listed in B minus A. Let's try to find out B minus A. B minus A equal to the elements which are in B but which are not in A are in B minus A. For example, 2. 2 is in A also, so we can take it. 5. 5 is also in A, so according to definition, it is not also in the set. Then 9. 9 is in B, but 9 is not in A. So 9 is the element. 11 belongs to B, but 11 does not belongs to A. So I will consider it. So this is a set of B minus A and this is a set of A minus B. After taking the example, we have proven that A minus B is not equal to B minus A. You have to note it. A minus B is not equal to B minus A. When we find the set difference, A minus B is not equal to B minus A. That means the operation of set difference is not commutative. It is not commutative. We have already seen. So this is our third operation on the set, that is set difference. And now if I take another example of symmetric difference. What is symmetric difference? Symmetric difference is nothing but let's take an example and I will show you what is symmetric difference. Okay, set A and set B, that is 1, 2, 3, 4, 5. B is 2, 3, 2, 6, 7, 5, 9. ठीक. What is symmetric difference? Very firstly, the symbol of symmetric difference is like this. A plus surrounded by a round shape. That is a symbol of symmetric difference. And what is symmetric difference? Symmetric difference is the element is either in A or in B, but the element cannot be in both of them. The mathematical definition says A, symmetric difference B is equal to X, where X belongs to A and X is not belongs to B, or X belongs to B and X is not belongs to A. What is the definition is saying? Let's have a look. X belongs to A, but then X should not be belongs to B. If X belongs to B, then X should not be belongs to A. What does it mean? It means that we can't consider the common elements. We have to take the element of A, element of B, only accept the common element. Okay, remove the common element and consider all other element, you will get the set of symmetric difference. In other words, I can say that A symmetric difference B is, what is this? This is A minus B. It is a definition of A minus B, we have already discussed. This is a set difference of A minus B, that X belongs to A and X is not belongs to B. So this or this, that means union of A minus B and B minus A. What is B minus A? B minus A is X belongs to B and X is not belongs to A. So symmetric difference is A minus B union B minus A. You can find the difference between A minus B and B minus A and take the union, you will get the set of A symmetric difference B. Let's take the example of this. Firstly, I will find A minus B. What will I get? A minus B, the element which are in A but not in B. So I will take 1, 2 is already in B, I can take it, then 3, then 4, 5 I can take because it is in B. So it is a set of A minus B. And what about B minus A? B minus A is the element of B which are not in A. For example, 2 is in A, 6, 7 and 9. 6, 7 and 9, because 2 and 5 are in set A, we can take it, I have already mentioned. So this is a set of B minus A and this is a set of A minus B. And now what I have to do is union of this and this. You have to take the union of this set and this set. What will I get? I will get the symmetric difference between A and B. What is the symmetric difference? 1, 3, 4, 6, 7 and 9. This set I get, this is a symmetric difference of A and B. What I get basically is all the element of set A, all the element of set B, but I remove the common elements, that is nothing else. I can get it directly from both the set. Start from the first element, list all the element, only remove common element. For example, 1, 2 is a common element, I am not going to take it, 3, then 4, then 5 is a common element, I am not going to take, then 2 is a common element, I am not going to take, then 6, then 7, then 5 again a common element, then 9. So after seeing both the set, I can directly get the set of A symmetric difference B. This is same as I get it from the mathematical definition, that A symmetric difference B is equivalent to A minus B union B minus A. So I firstly find the set of A minus B and set the set of B minus A and take the union of both the two. So these two are exactly same. You can find it either way which you get to know. Okay, so this is the operation of symmetric difference. And the last one is complement. What is complement of a set is, so before discussing the complement of set, you must know about the universal set. What is a universal set? You have already heard the name of universal set in our last lecture. So if I talk about universal set, that is a set that is containing all the elements of two sets. For example, it is denoted by U. U is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, I am saying this is a universal set. Universal set of set A, set B. Set A is 1, 2, 1, 3, 5, 7, 9. Set B is 2, 4, 6 and 8. What does it mean? It means universal set containing all the elements of set A and all the elements of set B. So this is called the universal set. Now I am going to discuss the operation complement. What is complement? It is denoted by, if I want to complement of set A, I can denote it by this A dash, then I can denote it by A powered by C, I can denote it by A bar. Okay, these three are the representation of the complement of the set A. Okay, now how to find the complement? You have to find the complement by A bar is equal to universal set minus set element of set A. Okay, that means the remaining element. For example, if I have a set A 1, 3, 5, 7, 9, what are the remaining element? Remaining element are 2, 4, 6 and 8. That will be in the complement. That means union minus set A. This is set difference operation, and you already know the set difference operation is the element belongs to this set but element does not belongs to this set. So we can find the set difference by the set difference definition. What is U minus A? That is 2, 4, 6 and 8. So this is the complement of set A, and if I found the complement of set B, what is this? This is U minus set B. U minus set B, elements of set B. So this is U and this is B, 2, 4, 6, 8, and if you minus U minus B, then what will you get? B bar equal to 1, 3, 5 and 7. So this is a set of complement of B. So we have already seen union, intersection, set difference, symmetric difference and complement. These are the operations on the set. These all are operation on the apply on the every set. You can apply on any set you can get. Okay, these are the operation on the set.